5'8". Um, so supposedly my Twitch stream should be fine as well. Okay, we're Gucci. Excellent. Dude, my man will just making sure I have my streams in order. Dude, thank you so much. I really, really appreciate it. Yeah. Mhm. Okay. So what do we want to do today? Hey, there we go. Thanks, man. Let's see. Let's see. Oh, fine. Fine. Oh, that's good. Let's go to creator dashboard. So I've already set this up neatly on my Ubuntu setup, but I don't have it on my Windows setup. There we go. There's well. I don't have it on my Windows setup, where I normally play my games. And man, I've been playing games. I am so happy. So this is the data set that we're gonna read and explore, and then we'll start off with talking about Hugging Face. So it can be like an introduction to machine learning, AI, and reading research papers and finding where we fall ourselves there. But I've been playing a lot of games recently. More notably, I've been playing a lot of Project Zomboid. And I remember I've mentioned this to Will already before. So Project Zomboid is this zombie survival game. Super duper fun. Um, and I've been playing in a multiplayer server, and it's nice because like you're struggling to survive, but then you encounter some survivors as well. Some survivors pillage and loot, but and hoard such that you don't have enough for yourself. But I've reached the point where I'm able to like fix up my car and tune it and have some sort of a safe base that I'm able to like help out newer survivors who are new to the game, um, and show them the ropes, like give them tips on how to actually play it. So it's super duper fun. This is a screenshot from the armory that we have in the second floor. Super duper fun. Some shenanigans that me and my friends were playing back then with Lewis. But yeah, so I hope to make more content about video games that I play. But what I did commit to myself was that I would be making more content later on in around 6 to 7, probably doing studying, right? So gaming classroom concept, studying between 6 to 7 p.m. and then playing maybe 7 to 9, or maybe 6 to 8. I'd be studying, then 8 to 9 I'd be playing, and opening it up to other people who want to play with me. So yeah, another thing I wanted to bring up is this cool lighting that I have set up. I'm so happy that I got this fixed it up. Also, just tweaking the lighting for this front light and the back sides. It's Gucci, super nice. Um, yeah. Mhm, mhm. A yeah. Um, I hope you've been doing well. Will, how are you, dude? Setup is lit. Let's go. Yeah, man. Dude, um, I'm good, man. Hey, you're upgrading your workstation. Like, what's new? Anong balita? Hmm. What was this? Your desktop? Your desk? Is it your desk that you're improving? Dude, it is such a pleasure to have a standing desk. I feel like it's one of my favorite furnitures that I bought. So like I bought my gaming chair sometime in 2020, I think, 2021, and then I eventually bought my standing desk in late 2021, early 2022, I think. Dude, I'm excited for you. It really motivates me to work hard because I've been taking care of myself, my tooling, my equipment. Dude, it's like when I discovered this one. I'm not entirely sure if people are familiar with this, but there's this font with programming ligatures, which is basically what you can have when you have like fancy ass fonts. So like if you do not like exclamation point equal sign, it'll translate it into an unequal sign. So plus plus becomes this one, minus minus becomes that one, right? Um, or without ligatures, like not equals would look like this, but not equals would look like this. So really pimped out. Feels good, man. So definitely my back hurts after long hours of work. Yeah, man. Yeah. Um, I get you. I know how that feels. I've been recently working out a lot. Like I've been jogging, which is really fun. Um, uh, and I find the jogging, like I'm doing this routine where I regularly have this jogging route that I take, and I measure myself every time. So I've been using Strava and another exercise recording app, and it feels good. Like I'm the more that I do it repeatedly, the more I can see the differences between every time that I do my runs. And I've actually been also doing this thing, which I'm gonna show you right now. Um, so I have this little notebook here, which has pencil writings, but it talks about my laning stage for the Dota heroes that I've been playing, and then it describes so every time you play Dota, it's a completely different game. So you're playing with completely different people and different heroes, right? So there's so much variability to the scenarios, but there are overarching concepts and aspects to playing the game that you need to understand to be able to play effectively. Like there's that: are am I strong in this lane? Should I be trying to go for kills, or should I just be playing conservatively and figuring out when to exit the lane? Um, Having those kinds of mindsets early on before the game actually starts is really helpful, because at least you know what to predict. You're not being a dumbass trying to get kills when you're not supposed to be, because it's a unfavorable matchup, right? Like the enemy's gonna be really stronger earlier versus you. So I brought that up because there's also that variability when it comes to, or that reduced variability. Is there some music here playing? Yeah, there is. Okay. So I was just having a weird thing happening on my headset, but yeah, there's that weird, there's that case where I'm doing my jogging and it's exactly the same route, and I'm doing it at the exact same time again. So there's very minimal things that are changing, and I'm able to like observe. Oh, okay. So when I do my route, I actually do my sprint up to 50% of the route, take a break, and then do another sprint to 30%, take a break, do another sprint of 10%. I'm at 90% completion, take a break, and then I finish. So now that I see that pattern, I can actually like, oh hi, I can try to push myself even more. So it's super fun. It's basically playing games in real life and just trying to take care of my body, adulting. But yeah, um, so I'm gonna probably start off and talk about Hugging Face. Yeah, dude, optimizing exercise routines and good habits, like we do with our practice in software engineering, right? Yeah, so I'll talk a little bit about Hugging Face. So let's see what Hugging Face says if you're logged out. So I have an account. So it's the AI community building the future. Build, train, and deploy state-of-the-art models powered by the reference open source in machine learning. So they're establishing themselves as that reference, right, for open source machine learning. So in Hugging Face, they have this. They have these different kinds of models, and they have access to data sets. And then you can also try out different. You can actually test the AI stuff that they have. For example, the goal of life is something like a mask, right? So you can choose a certain model, and then the computer can infer what it is, right? So it's loaded a lot of like data sets about language and literature and stuff. And the highest predictions that they found was happiness, survival, salvation, freedom, unity. And performances would differ depending on the model that you run. So it's super fun. There's different kinds of tasks. So there's inferencing, right? If you're trying to do natural language generation, And there are other kinds of tasks like image classification. Is this a cat? Is this a dog? Question answering, summarization, etc. So I'm just gonna go log in. There's this cute data set that I liked just 2 hours ago when I was looking for data sets. It's basically a data set that has text, and then the thing that it's associated with or labeled with is a picture of a Pokemon. So a drawing of a green Pokemon with red eyes. Ah, that's Bulbasaur, right? So the thing that you can produce with this kind of data set is like you give it a piece of text and trying to get it can try to guess which Pokemon is the closest one to your input text. So it's really cute. I like it. It's interesting. Um, yeah, I don't think that there's a particular uh, what do you call it? I don't think there's a particular research paper that was published for it. But Justin Pinky, the guy who made it, published his GitHub um, example. Stable diffusion is great at many things. What the hell is this? Dude, this is sick. Okay, that's interesting. So it's in Python. hmm So I think the inputs here are probably two different pictures, maybe like Donald Trump and another Pokemon. They're trying to see like diffusion. I'm not entirely sure what that means, but uh, it to some extent melds the two together. So I'm not sure. So yeah, it's diffusing into something, right? So this is Yoda with one of the Pokemons. But okay, interesting. This isn't what I wanted to read up, but I kind of wanted to find a simple research paper, to see if I can still understand basic statistics, math, and machine learning and data and stuff like that. So it's been a while since I've been doing this because most of what I've been doing in the past few years is building distributed systems and leading engineering teams. So let's see. Um, so that's a brief introduction to Hugging Face, this cute data set. There's this data set that I found. It's called Electricity Load Diagrams. So it's here, Hugging Face. And it's basically some data about electricity load. So let's read about it, right? So it's coming from 370 Portuguese clients ranging from 2011 to 2014 in 15-minute intervals, if I recall correctly. It's measured in kilowatt hours. So that's the electricity load that's used. And the values are in kilowatts of each 15 minutes. It was recorded in 15 minutes, but then it was rescaled, so it's multiplied by 4, right? So the kilowatt per hour values more accurately is like, yeah, it's divided by 4. Yeah, so what's my objective of actually reading this, right? So I want to look at what I can still recall from reading research papers and understanding the nature of the data set and being able to interpret what these numbers actually mean, right? There's a lot of records here. And I think it's an array, right? And it might be the full array of data within this day, I think. Mhm. It's a huge ass array. And then the next one. Um, and all of this is like 2012-0101, 2012-0101. The difference is this feet static cat. So I'm not entirely sure if this is like, is this the distinguisher for like which of the 370 Portuguese clients was involved? Possibly, maybe, I'm not entirely sure. But that's like what the whole point is, right? So I want to demonstrate how I would be trying to recall context about how to read research papers and what makes sense. And I'm going to be practicing communicating clearly what I feel I'm confident in and what I'm not confident in, and then just adjusting my understanding of what makes sense and what doesn't. So yeah, that's one of my guesses. This might be the marker for which person it is. I'm not sure what item ID is, or maybe this is some kind of classification. I'm not entirely sure, but this is definitely what day. And I think this target sequence is literally the different 15-minute intervals, because there's like 1, 2, 3, 4. So if we have 24 hours, 24 hours times 4 is 96
Hey,
measures.
what's up, my guy?
Hey, wait, wasn't that my voice? Huh. I think I just surprised myself from hearing myself. What was that? Oh, I think it's. Am I? Wait, I think I'm online on the gaming platform. No, I'm not. I just heard my voice. That was weird. I don't know. Okay, going back to what we were doing. We were reading the part, right? Okay, so I was saying that if this is recording a measure every hour, but it actually measures it actually in every 15 minutes, then there would be 96 measures. And that's what I think this whole set of data is. I think these are 96 entries. So this is 4, 8, 12, 16. So that's 16. So I'm just putting my thumb and just estimating this. So this is 16, 32. So this is 32. It's 32, 64, 96. No, this is a lot more data points. So I'm not entirely sure. Or maybe this is for the whole year? I'm not sure. Screw it. I don't have to get everything just from this point of view. So we'll just move on and continue reading. Yeah, dude. I don't know if you guys heard the sound in my head, dude. Like there was Darren who was saying, "Hey, what's up, my guy?" I'm like, so that's what I sound like. Okay. So the dataset has no missing values. They're talking about time zone changes. So when the time zone changes, like standard time, stuff like those changes, I'm not entirely sure because that doesn't really happen in the Philippines. But basically, there's a time period where time shifted, and it's basically 0 for all of those times there. Every year in October, time changes, which has 25 hours. The value aggregates the consumption of the 2 hours. Okay, so there's just that shifting that happens. Okay, fine. Data instance. So a sample from the training set is provided below. Here's an example. We have two configurations, UCI and LSTnet, which are specified as follows. Time series are resampled to hourly frequency. So that's what they said. They multiply it by 4, and then that's like the thing. So we test on a 7 rolling windows of prediction length of 24. The UCI validation therefore ends 24 times 7 times steps before the end of each time series. So maybe the training splits ends 24 times steps before the end of the validation. So maybe this array is a concatenated example. Yeah, basically it's smaller. Yeah, I'm still not sure what it means. For the LSNet configuration, split the training window so that it is 0.6 of the full-time series, and the validation is 0.8 of the full-time series. The last 0.2 is used as the test set, right? So it's just proper data set, splits that you'll need. Sets of 7 rolling windows of the 24 time steps each. So as I understand rolling windows, I think what it means is like, so if you're like doing it from hour 0 to hour 18, and then hour 18 to 20, hour 18 to 20 might be your validation set. So that's where you propagate back the weights for your neural net. It can happen that the next iteration would be starting from hour 1, moving to 24 hours forward, right? So it's basically just a rolling window of 24 time steps each, right? So it's 0 to 24, then maybe 1 to 1, just going to the next day. Okay, I think that makes sense. Data fields. For this univariate regular time series, univariate meaning just one variable, which is the variable is the electricity load, right? Regular time series. I'm not sure what regular means in a statistical sense. Um, Start is the first entry of each time series in the dataset, so that's the timestamp. Target is an array of the actual target values. Feed static cat is an array uint64 which contains a categorical identifier of each time series in the dataset. Categorical identifier in the dataset. Okay. Item ID is a string identifier of each time series in the dataset for reference. Yeah, so I think the category here is the person, right? There's 370 people, and I think that's what it means there. I'm not entirely sure why it was set as an array of uint, so I'm not entirely sure what to expect when there's multiple values here. But we'll see. That's okay. We're just trying to figure out what we can glean from reading a research paper in just a span of an hour. So let's keep going. Okay, UCI, LSTnet. I'm still not sure what UCI means. I think I've read a little bit about what LST means in the paper that they had. Dataset creation. So the electricity load diagram 2011 to 2014 was developed by Arthur Trindade and shared in the UCI machine learning repository. This dataset, this phrase is familiar because I encountered them when I was like looking for datasets as well in my master's research. I think this is like a community of. This is definitely a school. This is definitely a research lab. I'm not sure if it's in a school or if it's like a non-profit org or separate from a university. This dataset covers the electricity load of blah blah blah, with a sampling period of 15 minutes. Resample this to hourly time series. Okay, fine. Research development of load forecasting methods, right? So that's what they want to do. Their purpose is to perform forecasting. So you only see a set of the data first, so like hours 0 to 16. You do some predictions on hour 16 to, you try to predict what hour 16 to 20 would be. And then based on how you understood it behaved, you basically teach your model, and then you basically have your test set for like the succeeding ones, which would be like 20 to 24. That's how I understand it so far. Okay, da 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 da, and then they have this research paper. So at this point, Hugging Face provides the data set. It's already here. We can download it. Downloads last month 498, so there should be a download button here. Go to dataset viewer. Or maybe files and versions, right? Here's the dataset. Yep, dataset infos. So it's just in a Git repository. Yep. Okay. So normally what I would do next would be who made it and why did they make it, right? So here's the paper. So you can just click that, and it is submitted into, of course, one of the best places to submit your papers, which is ACM. I think this is Association of Computing Machinery something. I can't remember exactly. ACM, Association for Computing Machinery. Oh, so that was right. Okay. Yeah, but this requires that you pay to get access. That's a big oof. I do want to read the paper, but I want to read the whole paper, not just an abstract. So what we're going to do is we're going to research where we can read this paper. And if you're not familiar, there's a place called archive.org, which is another website. I think it's supported by Cornell. Greatly acknowledge support from the Simons Foundation's member institutions. So the authors here submitted, these authors also submitted to archive.org. And that's what open source is, right? Like you publish your work. So there's an option to download the PDF here, and that's what we're going to read to further see what we can understand from what they were trying to do. So let's see. Let's just read. We're not going to read everything, right? The thing that we're trying to practice here is being able to skim and just see key important things to notice, right? I'm definitely going to be moving at a pace that's a lot faster because I already have some background in machine learning and computer science that other viewers might not have experience in. But I will try to read and breeze through it quickly and try to simplify certain concepts just to recall as well how I understand it. It's not a guarantee that that's the accurate or perfect um, definitions of what I recall, but it's an exercise, right? That's what I'm doing. I'm trying to exercise what I can still recall from research papers. So let's go. Modeling long and short term temporal patterns. That's what LST is. LST. With deep neural networks, right? So I got to experience a little bit working with deep neural networks back in 2016, 2017, 2018 when I was finishing my master's. Um, I think I was more involved with using convolutional neural networks when I was working with images. Um, I'll try to recall the properties that I can remember from them, but let's read the abstract first. Let's bring it closer. So, multivariate time series forecasting. Uh, Multivariate, there's different variables or dimensions that you're looking at. Time series is over time. Forecasting, so it's prediction, right, is an important machine learning problem across many domains, including predictions of solar plant energy output, electricity consumption, traffic jam situation. Temporal data arise in these real-world applications often involves a mixture of long-term and short-term patterns, right? Just as like if you think about behavior in the stock market, there are overarching long-term patterns like the things promoted by technological advancement. But then there are also short-term patterns like short-term decisions that make certain companies go up and down, right? Okay, sure, that makes sense. For which traditional approaches such as autoregressive models and Gaussian processes may fail, right? Um, mhm, mhm. Um, so when I think about autoregressive models, the way that I think about this would be like linear methods, right? Like linear regression, right? This is basically just trying to have like a plot of data, and you're trying to find the line, right? That's why linear regression. You're trying to find the line that captures the central tendency of your data set. And you're trying to minimize the distance between the line and all of the points. And when you find that minimal distance, that's like, yeah, it's basically a predictive line. But then it has its limitations, which is what it's saying as well here. Gaussian process, the way that I understand Gaussian processes is like, um, in calculus, what I recall is that, um, is it related to calculus? Calculus is about changes over time. Yeah. Um, mhm. So if I were to like simplify how I understand Gaussian processes, the way that it makes sense in my head is, um, it's when you're trying to do minimization or maximization on a certain function. So for example, I am trying to maximize how much salary I can earn in my job, right? So you introduce certain changes, right? And then you see whether your salary actually increases or decreases, right? And when you say there's a Gaussian process, there's like some level of randomness that you introduce, like random behaviors, random actions, decisions. But then, uh, depending on how much you, depending on the randomness that you introduce, um, you may not get off the cliff of where you're stuck in your job opportunities in your market, right? So yeah, um, yeah, it's basically there's randomness and there's trying to do minimization or maximization. But okay, in this paper we propose a novel deep learning framework, namely LST, long-term short-term time series network, LSTnet. So this is their output, right? They're proposing this thing. This is in Carnegie. Oh, okay. Proposing this CNN and recurrent neural network to extract short-term local dependency patterns among variables and to discover long-term patterns for time series trends. Furthermore, we leverage traditional autoregressive models to tackle the scale-insensitive problem of the neural network model. I'm not entirely sure when CNNs and RNNs were discovered because I don't think this is uh, um, the root paper, or maybe this is one of the earlier papers of applying CNN and RNN into time series data. Maybe that's their innovation, right? It's the long-term, short-term in on a time series data set. Okay. Furthermore, we leverage traditional autoregressive models to tackle, okay? In our evaluation on real-world data with complex mixtures of repetitive patterns, LSTNet achieved significant performance improvements over that of several state-of-the-art baseline methods. All the data and experiment codes are available online. So normally what I like to do when this happens is I like to first see what the results are, because that's gonna motivate me to go like, huh, why did you how what did that look like? So I'm gonna skip over the introduction, related background. I'm gonna skip over that. We're gonna skip over this, recurrent skip. Yeah, so this is more of the theoretical component, optimization, evaluation. This is their method of evaluating or comparing the performance. And then they have these results. So let's look at the results, experimental details. We conduct a grid search over all tunable hyperparameters. So what this basically means is when you're doing machine learning and you're trying to generate a model, your model has parameters, right? Like it's gonna have, like, for example, um, we mentioned a while ago, for example, you might load your data set from time of 0th hour to 16, and then validate your model between hour 16 to 20, and then do your actual test set from between 20 to 24. That is like an arbitrary decision, right? Like that's an arbitrary decision. 16 hours for testing, 4 hours for backpropagation, 4 hours for actual model performance testing. But who says that 1644 is the best parameters or hyperparameters, right? So why not make it 20 to 2, right? So these are what you call hyperparameters. And when you say grid search, it's creating all the possible combinations. Not necessarily all, but like a lot of different combinations that you want to test so that you can run your machine learning algorithm and see how it performs given the different hyperparameters. So that's what grid searching on all tunable hyperparameters are. Held out on the validation set for each method and dataset. Specifically, all methods share the same grid search range of the window size. So there's the window size, so the parameters, blah, blah, blah. Okay. Um, let's see. Autocorrelation. This is time lag. So this is hours. Traffic data set, solar energy set, electricity data set, exchange rate data set. So likely this is the data set that we saw, the electricity load. And L is the sample rate, which is hour. Yeah, so I think it's this one. Recurrence. Okay, so I'm just skipping over it. I'm not reading it. Main results. Table 2. So it's this table 1. Where's table 2? This is table 2. Results summary. Table 2 summarizes the evaluation results of all the methods. Number 8. What's 8? All the test sets 4 in all the metrics 3. What are these references? Did they number their no, I think that's counting. Maybe that's just counting. So there are 8 methods on all the 4 different test sets, and there are 3 metrics. Maybe that's what it is. We set horizon 3, 6, 12, 24 respectively, because the horizon was set from 3 to 24 hours for the forecasting over electricity, from 30 to 240, and from 3 to 24 days. The larger the horizons, the harder the prediction tasks. So I think horizon is like how far off it is that you need to predict. Maybe. The best results for each data and metric combined is highlighted in boldface in this table. The total count of the boldface results is 17 for LSTNet skip, one version of the proposed LSTNet, and 7 for LSTNet attention. So I think so they had so basically they tuned a lot of different hyperparameters, and these are the numbers of the different ones that performed the best. I think that's what it's trying to communicate. Mhm. Clearly, the two proposed models, LST, NetSkip, and Attention, consistently enhance over the state-of-the-art datasets with periodic patterns, especially in the settings of the large horizons. So let's see what it performed, right? So there's a lot of bold faces, which means that it's the top performer. Mhm. RSE. I think this is like something squared, something like that. Let's see. What RSE meaning statistics? Relative standard error. Okay. Let's read what it is. Is equal to the standard error of a survey estimated. No, we're not looking at it. They multiplied by 100. The number is multiplied by 100, so it can be expressed as a percentage. Standard error divided by estimate. It's the mean of the sample. Ah, right. Okay. So this basically means how many times it errored, and then it's comparing to the rest of the other things that also can potentially have errors. Okay. Each column compares the results of all the methods on a particular dataset with specific horizon value, 3, 6, 12, 24. Boldface indicates the best result, yeah. And number 4, the total number of boldface results of each method is listed under the method name with parentheses. So this isn't the number of the performance or the which hyperparameter configuration it had. It's how many bold entries it had. And this is saying that it found 17 best performing stuff on this model and 7 here, which blows away the rest of the state of the art. Okay. Horizon. Core. What's core? They likely explained it in the evaluation. So let's read some more. Besides, LSTnet outperforms the strong neutral baseline by 9.2%, 11.9%, 22.2% in RC metric solar respectively, when the horizon is 24, demonstrating the effectiveness of the framework designed for complex repetitive patterns. So I'm curious, one question that I don't know, or don't know the answer to is, what does it mean when the horizon is 24? My guess is that it's how much it needs to predict. I think that's what I think it means. If it says 3, then you need, I think it's tasked to predict 3 hours ahead or 3 units ahead, because it might be normalized for the different data sets. What's more, when the periodic pattern Q is not clear from applications, user may consider Attention to as an alternative over skip, given the former still yield considerable improvement over the baselines. But the proposed LSTnet is slightly worse than AR and LRIDGE on the exchange rate dataset. Let's see that. So you take exchange rate. These two did not perform well. That's why there's no bold here. But AR and LRIDGE performed better here. So they're asking the question now, why? Recall that in section 4.3 and figure 3, which we did not read at all, we used the autocorrelation curves of these datasets to show the existence of repetitive patterns in the solar energy, traffic, and electricity datasets, the 3 ones. But not in the exchange rate, right? So there are repetitive patterns that can be found in the exchange rate. So I think this is like probably Forex, right? So yeah, and I don't think that the patterns that you'll find in the stock market are repetitive in a predictable manner as compared to energy consumption or traffic behavior. But okay. LSTnet models in modeling long-term and short-term dependency patterns. Models in modeling long-term and short-term dependency patterns when they do occur in data. The current results provide empirical evidence for the success in modeling long-term dependency patterns when they do occur in the data. So if you have an assumption, or if you feel like your data has those kinds of long-term and short-term patterns, then these models will perform well. So it's a question of how well you understand your model. And they also demonstrated how they did their analysis to uh, how to double check if there are those kinds of patterns, right? They discussed in section 4.3. Okay, clear, sure. I don't want to read it, but we can just skim over it. Compare the results of univariate AR. So I think this is AR. Um, with that of multivariate baselines. We see that in some data sets, solar energy and traffic, the multivariate approach is stronger but weaker otherwise, which means that the richer input information would cause overfitting in the traditional multivariate approaches. In contrast, LSTNet has robust performance in different situations, partly due to its autoregressive component, mhm, which we will discuss further in section 4.6. Oh, it hasn't been discussed. No, 4.3 is when they discuss it. Okay, ablation study. What does ablation mean? I don't know what this means. The removal or destruction of a body part or tissue or its function. Okay. To demonstrate the efficiency of our framework design, a careful ablation study is conducted. Specifically, we remove each component one at a time in our LSTNet framework. So you incrementally remove parts and see how it still performs. Okay. First, we name the LSTNet without different components as follows. Without this one, without this one, without this one. For different baselines, we tune the hidden dimensions of models such that they have similar number of model parameters completed by the LSTNet model, removing the performance gain induced by model complexity. The test results measured using RC and Core are shown in figure 5.6. Figure 5. Several observations. I think figure 5 but no, this is figure 3. Several observations from these results are worth highlighting. Best results on each data set, removing the AR component, removing the skip and CNN component. Cause big performance drops, but not all. Cause the most significant performance drop. Best result on each dataset is with either LST skip or LST attention. The conclusion is that our architecture design is most robust across all experiment settings, especially with large horizons. As for why the AR component would have such an important role, our interpretation is that AR. So what does AR mean? I don't know. Is generally robust to the scale changing in data. To empirically validate this intuition, we plot one dimension, one variable, of the time series signal in the electricity consumption dataset, which is what we looked at from Hugging Faces, for the duration of 1 to 5,000 hours, where the blue curve is the true data and the red curve is the system forecasted signals. I want to see this. Figure 6. ¿Dónde está? Figure 6. This is the figure 5. This is figure 6, right? The true time series, which is in color blue, and the predicted ones, which is color red. Oh, fine. So this is the actual data, then the prediction. It's somewhat close. It's somewhat close. Okay. VAR. I think that's the name of one of their algorithms. Or VAR. It's AR with a certain adjective V. I don't know what V is. Inadequate will predict similar patterns for Fridays and Saturdays, and one for Sundays and Mondays, while LSTNet successfully captures both the daily and weekly repeating patterns. Oh. What's A? Oh, this is AR. And B is with a one with skip. I feel like this is closer, right? Like this is a lot better than this one. There's like huge gaps here, right? But this one fits really smoothly, very snug, very impressive. Okay, let's keep going. Now we can see that the true consumption suddenly increases around the 1000th hour, and that LSTNet skip successfully captures the sudden change, but AR fails to react properly. Then they basically verify their assumptions. Okay. Randomly generate an autoregressive process with a scale changing by the following steps. Firstly, we randomly sample a vector, W, which from 0 to I, where W, the value of W is an element in all of the real numbers, where P is a given window size. Okay, then the generated autoregressive process, X sub T, can be described where the mean up to 1. Hmm. Cryptic. I don't completely understand it. Hmm. Inject the scale changing, increase the means. Yeah, the notations are escaping me. I can't recall what this, how this is completely read, honestly. Um, yeah, my understanding of this one is like it's an element of, right? Like the possible values of W would be within this range, but this one isn't completely clear to me. We increase the mean of Gaussian noise by some uh, mean sub zero every t times that. Then the Gaussian noise of time series x sub t can be written as. Yeah, so they're expounding that the thing that you're adding is passes. I think this n is basically there's a function that they're doing. Mhm, mhm. And this mean is basically expanded into this part. It's the floor value of the, what's t? Yeah, the floor function, right? We split the time series, the training set. Yeah, I'm not entirely sure what small t is. Maybe that's the current time. What's the big T? It's the timestamp. How does that make sense? Floor value. Right. So it's approaching the mean ahai. Ahai. So what this is saying, as if I were to try to guess what it means, um, time over time is basically a progress bar, right? At the start, it's gonna have like some small value, 0 out of 100, 1 out of 100, 2 out of 100, etc. Then when you get the floor value, um, it's probably gonna drop to maybe like, if it's 1.7, it's gonna become 1, right? If it's 2.75, it's gonna be 2. And then you multiply it by the mean. Um, and then n, I'm not entirely sure what n means. Or maybe it's just choose a random number. Maybe that's what it means. We randomly sample a vector w. Yeah, yeah. Maybe that's the, it's choose a random number between the incrementally progressing multiplied to the mean up to 1. Yeah, I'm not entirely sure. I feel like 50-60% confident in how I understood it. Mhm. The result is illustrated in figure 4. Both R and N can memorize the pattern in training with the side left, but the cannot follow the scale changing pattern in the test side. Mhm, mhm. In other words, the normal RNN module, or say the neural network component LSA, may not be sufficiently sensitive to violated scale fluctuations in the data. Yeah, so this is, yeah, because they're trying to test if it's scale invariant or scale insensitive. Mhm. Okay, so that's basically what they did. They are trying to see if they can produce a model that's able to predict uh, a model that when you train it with some data, it's able to pick up patterns in short-term and long-term patterns. That's why their title is Modeling Long and Short-Term Temporal Patterns with Deep Neural Networks. Alright, cool. Okay. I think at this point, I have a general enough uh, idea of what their paper is trying to do. And this is the point where I would probably read a little bit more on the theoretical framework. So I'm trying to understand more, how does it actually work? Um, how did they? It's going to be a refresher for me about how um, CNNs, convolutional neural networks, and recurrent neural networks work. Um, mhm. um, yeah, yeah, okay, let's do that. Um, so framework, theoretical framework, chapter 3. Okay, I'm gonna hard stop at probably 650 to summarize what I was able to pick up. But for now, let's just read a little bit more. And then probably at 7, I'm definitely gonna be playing games because I deserve the break. Yeah. Okay. Theoretical framework. Let's go. We first formulate the time series forecasting problem. So we have to define it as a formula and then discuss the details of the proposed architecture. Mhm. Mhm. Finally, we introduce the objective function and the optimization strategy. We are interested in the task of multivariate time series forecasting. More formally, given a series of fully observed time series, signals y, so y sub 1, 2, 3, etc., up to time t, where y sub t is an element of all real numbers sub superscript n, and n is the variable dimension. So if it's univariate, it's just one float value, right? But if it's multiple dimensions, then that means that y sub t should have multiple values. So it should be a tuple rather than just a single value. Okay. We aim at predicting a series of future signals in a rolling forecasting fashion. That being said, to predict y sub t plus h, where h is the desirable horizon ahead of the current timestamp. Ah, so that's what the horizon is. So when you say h24, predict what the 24th uh, uh, offset would look like. Um, So in the example a while ago, it's a rolling it's a rolling window kind of thing. So if for example you were fed data from time of 0 to 8 and your horizon is 3, then you're trying to predict what the electrical signals are or electrical load would be at time 11, right? So 3 hours ahead for horizon h equals 3. Okay. Likewise, to predict the value of the next timestamp, which is y sub t plus h plus 1, which is the next one, we assume y sub 1, y sub 2, y sub t, y sub t plus 1. We assume that they are available. We hence formulate the input matrix at timestamp t as x, which is usually the input, right? F of x, sub t. So the input at time t is equal to y sub 1, y sub 2, up to y sub t, which is an element of all real numbers given n dimensions times t, which is how many what is t? T is the timestamp. Uh-huh. Mm-hmm. So my understanding here is when you say it's a rolling window, the timestamp t is basically saying timestamp 0, right? Your rolling window is 7. So 7 is your count here. So there's going to be like at hour 0, hour 1, hour 2, blah, 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 and then hour 6. Mm-mm. Okay, sure. Let's just move on. In most of cases, it's kind of weird phrasing. The horizon of the forecasting task is chosen according to the demands of the environmental settings. Example, for the traffic usage, the horizon of interest changes from hours to a day. For the stock market, even seconds, minutes ahead forecast can be meaningful for generating returns. Yeah, it's basically doing forecasting, right? Like that's what you want to do. Figure 2 presents an overview of the proposed architecture. I think this is this one. Okay. The LSTNet is a deep learning framework specifically designed for multivariate time series forecasting tasks. So it's great because it's multivariate, so you can scale it down to just a single variable if you want to, but you have the flexibility of like modeling multiple variables if you needed to, with a mixture of long and short-term patterns. Okay. In the following sections, we introduce building blocks for the LSTNet in detail. So we talk about convolutional networks. Let's look at the picture first. So this is interesting. It's been a while. This has been a really long while. So there is time series data, and there is this rolling window, right? There's a set of data. So this would be your multiple variables. This is your rolling window. Like if you have like two, if your window size is two, then you have this one, right? And then it's just moving forward. Um, mhm. And as I understand this, there's different layers to the model. So there's the convolutional layer, then recurrent skip layer, and I'm slowing down my words because I'm trying to also understand what I'm saying. Um, okay, so we have recurrent and recurrent skip layer, mhm. And then fully connected in element-wise sum output. Mhm. So the output of the convolutional layer can be fed into the RNN, right, the recurrent neural network, or it can also be part of the output network already. Um, mhm. And this is autoregressive, so, and then there's a linear bypass. My understanding of what this is that part of the prediction model depends on not just this um, network that you produce, which is a combination of your convolutional layers as inputs, but also your RNN as inputs. It also has a linear model that it uses as input in the prediction model. That's what I understand. But let's see if that actually makes sense. The first layer of LSTnet is a convolutional network without pooling. Okay, so I forgot what pooling means. So let's see. What is pooling in machine learning? Pooling layers are used to reduce the dimensions of the feature maps. So it's basically saying we're not going to do any dimension reduction, right? Yeah, to reduce the dimensions of the feature map. So if you have a lot of data, for example, if this is an image, you want to simplify the image first, it becomes 9786. And the algorithm that it uses max pooling. It just gets the maximum value in the section. So what I understand from this is basically without pooling, we're not trying to reduce dimensionality. Like whatever the input is, we process it as it is, which aims to extract short-term patterns in the time dimension as well as local dependencies between variables. The convolutional, mm, so mm, to extract short-term patterns in the time dimension, right? As well as local dependencies between variables, right? Because you might have variables here that have, correlations, um, but then there might also be patterns across time, right? Like let's say every 8 o'clock, uh, 8 in the morning, electricity consumption actually spikes by this factor, right? So those are the kinds that it's trying to detect. Okay. The convolutional layer consists of multiple filters of width and height. Width and height. The height is said to be the same as the number of variables. The kth filter sweeps through the input matrix X and produces H sub k, which is equal to the rectified linear unit. I think that's what it calls. Rectified linear unit activation, right? So we'll get back to that. The ReLU of W. What's W again? ¿Dónde está? Explain your W. Where's W? No W. With W. Where's the big W? Where is the big W? Maybe this is the small W. This is kind of frustrating because it's not. It's either my reading comprehension is low or it's not labeled properly. We make each vector h sub k of length t by zero padding on the left of the input matrix X. The output matrix of the convolutional layer is of size d sub c times t, where d sub c denotes the number of filters. What is this doing? There's an input matrix, then you have another Okay, W sub k is basically the weights of the model. Okay, the weights of the model. So okay, plus B sub k. What's B sub k? Okay, what is k? The kth filter sweeps through the input matrix X. So I think there's multiple. Are these what they call filters? Hmm. Where star denotes the convolutional operation. Mhm. W sub k is this. Okay, so going back to what CNN is, right? So yeah, it's not the news company. Um, the way that I recall CNN is that if you're dealing with matrices, do we have a wiki here? You have a matrix of data. Um, let's look for a visual example. There we go, this one. So you might have an image. So convolutions is like you create these layers, right, or feature maps. So it might be what they mean with this one. Um, but basically, you have this convolution operation, which is what they mean here when they say this asterisk denotes the convolution operation. Convolution operation, as I recall it, is basically there's this small like square that you're processing within the data or within your input matrix. So I think the strength of convolutional neural networks is that it has properties of shift invariant and space invariant uh, invariance. What I like, I'm like my confidence here is like really low, like probably 20%, 30% confidence. But what I recall from that is basically um, you might be able to train a machine what a cat looks like. But just because the cat is here on the upper left doesn't necessarily mean that if the cat is on the lower right, it's gonna have a hard time finding that cat because it's only shifted, right? So a shift invariant model is one that is resistant to shifting of the data, right? So in the context of what we're reading here, those are the properties that it's trying to see um, when it's doing this kind of like temporal analysis. Like there might be patterns that it's seeing even if you adjust it on the time period. That's how I understand it. Okay, let's read a little bit about convolutional network just to see. In deep learning, a CNN is a class of artificial neural networks most commonly applied to analyze visual imagery. That's why maybe that's their novel introduction, right? Introducing CNN into a temporal space. Um, CNNs are known for shift invariant or space invariant AI, artificial neural networks, based on shared weight architecture of convolutional kernels. There, yun. So the kernels and the filters, that's what they're called. That's what these square things are that moves around and tries to do subsampling or doing the convolution. Okay, so let's go back here. So the kth filter, so it's producing the filter or the kernel, right? So the filter sweeps through the input matrix X and produces H sub k. So X is your input, likely W sub k is um, your filter or your kernel. Mhm. Consists of multiple filters of width W and height N. Width W, pwedeng 1, and height N, which is multiple. Okay. Okay. We make each vector H sub k of length t by zero padding. Okay. The output matrix of the convolutional layer is of size d sub c. What is d? What is d? Where d sub c denotes the number of filters. Okay. 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 So that's CNNs. Let's now look at the recurrent component. So let's read RNN wiki. What time is it? 6:52. Okay, we should be wrapping up. So let's just read this briefly and then go back. A recurrent neural network is a class of artificial neural networks where connections between nodes can create a cycle, allowing output from some nodes to affect subsequent inputs to the same nodes. Um, mhm. Yeah, so it looks something like this, right? You have a function called h. It has an output O, but the output O can also be an input to its future iteration, right? So you produce an output. This is my prediction currently, but then your output is so like if you think about your phones and your auto predict when you're typing, it's actually using those kinds of um, artificial or recurrent neural networks. Like if I don't know if you guys are familiar with SwiftKey, but it's an app that lets you swipe on your phone and it basically predicts when you click the prediction that you wanted, right? Um, so it can see the things that you pressed, and then it basically feeds into getting better and better and in modeling how to predict what you actually frequently write. Um, okay, let's go back. Fully recurrent connects the outputs of all neurons to the inputs of all neurons. This is the most general neural network topology because all other topologies can be represented by setting some connection weights to zero to simulate the lack of connections between those neurons. So pwedeng pagbalik niya dito nakaset to zero or something, right? That's like a simple, hindi technically hindi na siya recurrent sa ganun. But, um, mm, yeah, the lack of connections between those neurons. The illustration to the right may be misleading to many because practical neural network topologies are frequently organized in layers, and the drawing gives that appearance. It's not layers, it's over time. However, what appears to be layers are in fact different steps in time, exactly, of the same fully recurrent neural network. It's the same machine. It's the same models, pero nag-a-adjust siya because of the inputs it being fed into. There's another model, Markov chains. But Markov chains is more of modeling parang different states. So it's a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. So I think this is another one of those parang feeds into itself kind of thing. Kasi the prediction to where you would go can be the input to the next part, right? So if, yeah, I'm not gonna dive into it some more because we're lacking in time. But okay, you can explore it some more. The leftmost item in the illustration shows the recurrent next. Yeah, okay, fine. Let's go back. Output of the convolutional layer is simultaneously fed into the recurrent component and recurrent skip component. So this is what they're talking about, right? So we have the recurrent and the skip layer. I think recurrent skip is basically the combination of recurrent layers and having things included in it. And I think this one's the purely recurrent one. But I don't know, that's a guess. Uses the ReLU function as the hidden update activation function. The hidden state of recurrent units at time t is computed as formulas, where is the element-wise product, sigmoid function, sub t. Okay. Recurrent skip. Current layers. Yeah. Okay, so I'm probably gonna take a step back and say that these are interesting things to read some more later. But I'm Gucci. I'm pretty satisfied. I'm pretty satisfied because I was able to recall stuff that I've been studying way back. I can still feel confident about reading research papers. So yeah, I'm happy about that. Mhm. Okay. So stepping back, let's go to game classroom. So that's our actually we can just go back to stream start, right? Okay. So that was an experience. It was interesting to go through. Yeah. So that's basically like a refresher of me trying to remember my statistics, my machine learning background, and that's fascinating. That's all good. There is something that I do want to build out as a machine learning project. And if there are some people who are interested to try learning machine learning and AI with me, feel free to just drop by the gaming classroom, right? So we have a Discord channel. You can find the gaming classroom in my website, sapalo.dev. And if you go on the bottom side, you'll see the gaming classroom, right? And this opens you up to the link to join us on Discord. Um, is it this one? I think it's this one. You can get your roles here. I think there should be a button here to join the Discord community. So I'll add that in. Oh, I'm not showing my screen. So this is what I mean by my website. So sapalo.dev. And if you scroll down to the bottom, you see the things that I'm building, which is the gaming classroom and tome.gg, right? So you can go to the gaming classroom if you're interested to study with me, machine learning and AI stuff. So I'm going to be doing machine learning and AI for the products and technical things that I'm going to be building for tome.gg, which is my educational and gaming platform. Yeah. So I'm going to add the button here to join the Discord channel, but this should direct you to the Discord channel already if you're part of it. Yeah. Yeah. I think that's generally it. Yeah. I'm gonna be playing games now, so I'm gonna turn off the stream, switch it up to a gaming setup, and yeah, I think I'm gonna go play. I'm gonna go be masochistic and play Dota 2. Uh, yeah, why not? Why not? You know, yeah. It's hard as hell, but you know what? It's a game I love to play, so let's play it. Because I'm considering playing Zomboid, which is super fun. Maybe we can play a bit of Zomboid, walk you through the places that I've been doing and stuff, and probably think about gaming concepts that I enjoyed in Zomboid, so that it's already content that I'm producing over Twitch. And now that it's content that it's on Twitch, I can just rip it off and then produce it into TikTok, right? I think that makes sense. Do long form content and then produce it. All right, let's do that. Um, yeah. So thank you for joining me today. Um, we have two viewers. Good stuff. I think this is my friend who's also streaming. I think in probably what do you call this? I think this is Michio. I think. I don't know. But if I recall correctly, he has a schedule, I think. Oh no, last stream last year. Okay, so this likely isn't my friend. But there, I'll just check if one of my friends is online. And then we can probably just direct them to their channel. How do I find out which channels I follow? I'm not entirely sure. Who do I follow? Recommended channels, follow channels, okay. Um, Nobody's online. None of the friends that I know of. But there's this guy that I'm following. The average one. And he has ads. Okay. I think there should be a button to like raid the channel, right? Yeah, okay. So we can click that button later. But I just forgot what this channel was about. But what they're doing is they're playing Assassin's Creed. Yeah, I think this is the guy that I was watching the other time, who was playing Edge Runners, and I was super interested. I bought the game. I'm gonna be playing it as well, but I might not be streaming it because I'm gonna be playing it with um, special set of friends that I wanna. Yeah, I think this is fun. Yeah, and yeah, we'll just raid his channel and then. Oh well, technically I am gonna be streaming, so technically should I be rating channel? Oh, I don't know. You know what? Screw it. I'm still new to all of this Twitch streaming stuff. I'm just gonna go stop the stream, and then we're gonna go ahead and play. Let's do that. Okie dokie. Um, or you know what? I don't even have to stop the stream. We can just go stream start, right? And then we can probably switch up my stream information. And then we're gonna name it uh, you know what? Why not just go ahead and straight out play the game, dude? Like, we can just do that. Okay, so we're gonna play some Zomboid. There we go. I'm gonna walk you through this game called Zomboid, which is a pleasure. It's super fun. With how long it takes to load, makes me feel discouraged. Makes me want to just play Dota. There's a playlist that I actually listen to whenever I what do you call this? Whenever I play Zomboid. So we can probably listen to it. I think it was, where is it? Let's just pick it up. City of Gamers. I think it's this one. Yep. Let's go. So while it's loading, I'll just have my publications here. We're starting. Let's go. There we go. We're gonna join. So it's a Southeast Asian server. There's 3 players currently online. And yeah. So my username here is ForexHacked, which is a silly username. But the reason why I have that username is because back in 2003, 2004, I was playing Ragnarok Online. And I guess you could say I made 5 accounts. So what I like about Zomboid is how much you can actually modify the game. Like the modding community is like super cool. Um, they introduced a way for you to actually um, they really extended the game a lot, and like there's so many quality of life improvements that they created. Like there's one where in Zomboid, if you get bit by a zombie, like that's it, you're dead, it's done, right? They made a mod where you can find rare zombies that you can get some kind of zombie vaccine so that you can recover. And the name of the mod was They Knew. And the reason why they call it They Knew is because they knew about the zombie apocalypse. They manufactured it. That's why they also manufactured a cure. Um, Super interesting. I love the game. I love and hate the game. I think that's generally how it's like when the game is super fun, challenging, and competitive. You hate it. Like when it comes to playing Dota. I hate Dota. I love it. It's so satisfying to overcome. I guess that's what happens, right? When you choose your uh, stone to carry, like Sisyphus. Sisyphus is the name, right? Like of the person who is pushing a stone boulder. I think so. So welcome to my humble abode. So it appears to be raining. It's currently May 31. This is my character. His name's Andre Rubric. And he's all padded up. I've been patching up his clothes and stuff recently. Um, so yeah, this is my friend's card. I'm just going to close it. But then this is my card. Um, and it's all decked up, 85%. I love it. So this is my character. These are my health bars and stuff. My health, my hunger, my thirst. So I'm quite carrying a heavy load, and I'm peckish, or like I'm basically want to eat. So one of my friends recently came and gave me like a lot of food supplies, and in exchange, I basically tuned his machine, right? Because I have a lot of skills in metalworking and mechanics now, which is excellent, by the way. So I can easily fix up cars and stuff, which is something I didn't have before. So this is the kitchen slash garage, and what we're gonna do is we're gonna probably pick up some soup. Do we have soup? No. We'll just open up some can of peaches, and we'll just have a bite, right? So this covers 15 health. We're gonna just top it up, you know, just good amount, just so our health is actually recovering. Still not enough. We still have a lot of food, so we'll just open up some canned sardines. Then just grab it, eat 14 more points of health. We're carrying a lot of stuff. We're 18.6 out of 18 a while ago, but because we're well fed, we're stronger, so it's over 20. So I'm just gonna be hiding away all of my tools. Put it all here. But I also have a lot of tools here. There's a car battery type sport. I'm just gonna hide it here in our equipment. Alright, put it all here. And we're not overburdened anymore, overcumbered. So that's a lot of gunfire that you're hearing because of my schizophrenia trait. So I can hear things that aren't actually happening, and it stresses the fuck out of me. And sometimes I see zombies when there aren't any zombies. So I'm hearing some combat happening. Not entirely sure why. But it's raining. We'll probably do some gardening actually. I actually want to do some gardening a little bit while it's raining. Might as well. I think I have some. I cannot squeeze into this, man. I need to push my car out. Okay. So what do I want to do? Dude, I feel like I'm gonna be playing Zomboid. I'm definitely gonna be playing Zomboid. Okay, I'll play Zomboid probably until like 8, and then I'll play some Dota. Because I want to play Dota. I want to rank up and take my shit seriously. Where are the things for planting? On this side, is it here? No, it's in the crafting table. Let's go there. Okay, so we're probably gonna plant some cabbages and some radish, maybe, and tomatoes. Oh, we already have a cabbage. Okay, then we're gonna need some trowels because we be digging it up. Dig in, dig in. Not a shovel. We don't need a shovel. Where's the trowel? Trowel. Don't we have a trowel here somewhere? Are you serious? We didn't pick up trowels? Oh no. I think I put all of the. I think I put all of the. I think I put all of the. What do you call this? The equipment necessary here. I think. Oh no, maybe someone stole it. I don't know. Really, we don't have any trowels. Turawelu. Let's arrange by name. Letter T. Well, yeah. See, I knew we had a trowel. There we go. Okay. Let's go. Planting in the middle of the night, 3 in the morning. You know, just some priorities. Dig furrow. So the reason why you want to keep it in separate places is because sometimes your plots can have infestations and you don't want it to scatter to your other plots. Oh, I should probably change my thingamajiggy here on Twitch. So edit settings, and then this should now be reading research papers, then zombie games. Zombie. So okay, great, coolies. Next here. This one here. Next one here. And then let's put some more here. And then we'll probably build out some irrigation systems. We also have a lot of I guess the question here is, oh, we do have compost, so that's excellent. We're gonna get some compost. Get compost. Okay, and then what we can do is we can start off probably on the rightmost. We're gonna be planting cabbages. So seed cabbages. Alright. We'll go here. I don't have cabbages anymore. Let's open up some more. Cabbages are most resilient. That's why we're planting more of them. We can probably do 2 more. We're gonna do 2 more. No, let's do some radishes and some tomatoes. So we'll have this as a radish patch. Right, and then we'll have some tomatoes, right? So I'm definitely sure we're gonna have a lot of cabbages. So what I'm going to be putting fertilizer for would be the tomatoes. It stopped raining. So okay, then we'll put some more on the radishes. We don't have any more compost, so we'll get some more. Fertilize. Fertilize me. That's a reference to Doctor Who, by the way. Just a little something for my Whovians. We'll probably, well, not enough stuff. Okay, we can unpack this one now. Drop the sack. have some worms. Okay, but I bet everything's dry. I bet parched. The reason why I planted was because it was raining and I didn't want to water them. Alright, screw it. I'm not gonna be planting right now. Okay, probably should designate a planting box here. Just drop everything here. Empty tin can, that has a place. Should put it here. And if I recall, I have a lot of bandages. Sterilized bandages for my friend. Really thankful for that. We'll probably put it here in the medicine cabinet. Just drop everything here, and then I have like 3, which is good. And then we're gonna drop some bandage. Is my light open? Yes, it is. Hey, Sokulan is on. This is a friend of mine that I helped out. Okay, I'm gonna smoke a bit. Oh, Zomboid is actually covering my my map, so I'm gonna go ahead and put this over here. That's good. Okay. What do I want to do? It's 5 o'clock. Oh, great. Hey. Hey. How do I wave again? It's there we go. Fine. So we can add faction, add player. Is it ins? The hood's all broken up. You can probably fix this one. Engine's bad. Hi guys. I'm gonna go wash his car because it's full of blood. Wash vehicle, man. Okay. Car's in good condition, man. It's 32. Okay, we're gonna go ahead. Let's unload and prep for the raid. We can take both cars. Hey, let's go. We're going on a raid. Okay, so this military base that this random friend of mine, random stranger that I met online, walked me through on how to go to. Super fun. So let's probably put away our stuff first, stuff that we don't need. We're gonna need to put away this wrench. We're gonna put away this propane tank, which has nothing anymore. So let's refill this one. I'm gonna refill this one too. Okay, and then we'll put away this propane tank. Jack, unfavorite, lug wrench, welder mask. Do I really need to bring a welder mask everywhere? I don't think so. Yeah, I don't think so. Okay. Empty pop can, we have to throw that away. Aluminum, we have to put that away. Duct tape, we'll put it here. No, it should be somewhere in the proper place. Where's the duct tape place? There we go, duct tape. Duct tape, a lot of nails. Let's pull away the aluminum somewhere here. Or actually, let's put the aluminum here with the other tin foil stuff. Right, and then empty pop can. Weight 23 out of 36, still too much. It's because I'm carrying a wood axe. So we're gonna need a wood axe. But I'm not gonna carry. I mean, we can probably repair the wood axe, right? Yeah. Okay, repair. Take out this. Repair it to wood. Oh, hi. That's some conditions back. If we repair it again, 35%, 5. So wood glue is what fixes it best. I think we have wood glue. Oh, let's go. Oh, hi. Repair it, 35%. Oh, hi. It's in good condition now. Okay. We can probably carry it. Okay, fine. But we're gonna need to unload all of this. So much lug wrenches too. Yeah, right. Door knob, door hinges, car battery. Why are we carrying a car battery here? Oh, because I charged it. I didn't put it back. I should put it back. Let's place it here. Okay. Then we're gonna probably. I'm gonna. How do we? I don't know what to do with them. I don't think the lug wrench can be melted down, unfortunately. Okay. Okay, we're gonna drop the duct tape here. Gonna drop the thread leather strips. Actually, I kind of want to make sure that my pants aren't. Yeah, I saw a hole a while ago, so we need thread and stuff. So we'll get some thread. And then let's get some rib sheets. And then a needle. And then rib sheets. Okay. Oh, I think it's on the ground. Let's put it back in the right place. There we go. We're gonna have to put the tarp here. Somewhere in one of the car stuff. Tarp. Right. It's not fitting anymore. Why? Let's drop off the door hinges and stuff. Okay. Toolbox we can dismantle. So we'll do that one. Dismantle. Why isn't it getting dismantled? What's wrong? I have enough propane. I have welder's mask. Where's dismantle? Dismantle. Filter on. Dismantle. Why can't I dismantle heavy one? Because I'm not wearing a heavy welder mask. It's right here. It's right here. Why? It's still not happy, dude. What the hell? Dismantle heavy. We have a welder mask. What's this problem? It's right here. I'm wearing it, dude. I'm good. I'm feeling good. Yeah, there we go. But I don't want to just accidentally break something I don't want. Like, there we go. So I'm not supposed to be wearing it. Super weird. Just need all the scrap metal. Okay. Okay. That laughter is my schizophrenia. Scrap metal, we'll drop it all here. Okay. We'll wear this one, and then we'll wear this one. I don't have mag rounds anymore, which is annoying. Yeah, we're gonna be eating junk food. So who cares about nutrition, right? Dude, I am so fat. I wish I was this fat in real life. Oh no, I'm underweight. Oh, I'm overweight? No, I'm gaining weight, but I'm really underweight. I'm 61. Maybe it's because I've been carrying all of that stuff lately. Okay. So we're gonna put away the welding mask. Welding mask. We'll put away the coffee. Yeah, the wood axe. We have a crowbar. I don't think we're gonna need the crowbar. Yeah, okay. We're gonna need the crowbar, but I don't think we should bring the Desert Eagle anymore, because it's too heavy. Yeah, that's generally it. You shouldn't bring it anymore because it's too heavy. And I don't even have that many bullets left, dude. I only had 2 left. What the heck? How are we gonna kill zombies with that? But I really like it because it's quiet, dude. I don't know. It's high. Okay, so that's what I want to get out of the thing, the exploration. I want to get bullets for my magnum. Donde está? Rifles, pistols. There we go. And then put in military crate. Okay. And then we're probably gonna use this as our primary weapon, the survival rifle. It has a lot of damage and long range. And we're gonna need some 5.56. ¿Dónde está 5.56? 55645, right? 55645. Yep. Okay. I'm gonna get some of our 125 rounds. Um, uh, I think this is enough to clear it, maybe. Yeah, okay. And then we have some of rounds. Yeah, we're lock and loaded, dude. Okay. And then we have a lot of stuff here. Should drop the candy package, the welding rods. We're not doing any welding there. So we'll drop this one. We'll drop the candy package over here. Candy package. And then the credit card, we can place it here so that if ever anyone wants to order food, they have it there. We'll drop the bandage here. We should probably put the sterilized bandages over here. And I have a padlock. Do I need the padlock? Not really. We'll drop the padlock here. Scissors, just in case. Okay. Let's smoke a bit. Okay, I don't need 2 can openers, which weighs 0.6. No. No bueno. We don't need 3 lighters. So put these away. I have an extra match. We don't need 2 needles. I'll put this one away. Okay. And I have more projectiles. Okay. And I'm gonna write on my volume. So here's another mod, right? So you can transcribe what you've learned into this journal so that if you die and you restart with a new character, you can actually have a percentage or all of it back. When I'm referring to like all your skills, because this is so painful to restart with a new fresh character. So I'm gonna tell my friends to also okay, then I'm gonna go pick up these Gucci stuff. It's a lot, dude. I'm not even sure if we have enough space. I will definitely have enough space, but we're already maxing out on our stuff. So just leave all of these ones here. Okay, we're gonna inject the magazine. We're gonna put some bullets in it. My reading material is by how much is this? 3 weight? It's not gonna fit here, is it? It's not. Okay. We can probably reduce this a bit, or not. Yeah, we can probably pick up some more painkillers, sterilized bandages. Okay, we're definitely getting into combat, so let's pick up some more of this. Suture needle just in case. Okay. We'll probably get some vitamins, beta blockers, antidepressants, alcohol wipes. Okay, so we're good. You can put this one away and put this one away. You guys were in what's that place? I'm gonna just drink up some drinky drink. Fill up all the empty water bottles that I have. Snorkel. The roof rack is so heavy though. Okay, let's run it. We have a lot of food, no problemo. Then let's just dump all of the stuff. Where is it? There it is. I've made that building before, so it's no bueno. Dude, that was crazy. That was a horrible travel. On my legs. Bus 11. Okay. We're here. Okay. We're dropping this one off. Thing is, this M998 is it's an issue. Use a can opener. And then I can get some. I need to unload this one. Oh, well, I already have it. Okay, get some gas here. Oh, no, not the. Take fuel, fill this one. Yeah, dude, super fun game, man. I love Zomboid. How's the generator actually doing? 33%, conditions 74%. Pretty good. Should probably just have to turn off the lights and stuff. Not waste some stuff. I can drop this one. Not sure if you have large gas tank already. If you can have that. I have 4 large gas. Okay, what was I doing? I'm gonna drink. I am thirsty. Thirsty AF. 5 water bottles. We need all that water? Okay, we're going on a long journey. I think they will appreciate it. If I ever make it to the Grand Ohio Mall, I live nearby, so too free. I've gone to the East Island. Really nice. Have you guys seen M998s? It's so weird. Okay. Bring food as well. Okay. Okay, I'm gonna bring us some Gucci Yum Yums. I'm gonna have some Happy Foods as well. Okay. All the foods, get out. Get off this Java. Okay. St. Peregrine Hospital. Okay. I have two screwdrivers. What's that? Okay, let's just drop the screwdriver here. Okay. What else? Batteries. Okay. It's gonna be nighttime. We should have batteries. Okay. Let's just pick up some batteries. Okay. I'm Gucci. I'm good to go. Wrote down my journal too. Ready to die. Just kidding, I don't want to redo metal with 10 mechanics now. Alright, man. Let's go. 3 viewers on Twitch. Hello and welcome to the stream. We are currently playing Project Zomboid with some random online stranger friends. Over here we have Sulky Lemon and Ains. And yeah, we're gonna be carrying our pimped out sports car over here. Why are we overburdened? Why is everything? Do we really need to bring a propane tank? I don't think so. Let's drop the propane tank. Okay. Do we really need 3 magazines? Maybe not. Maybe gotta take some odd jobs. Training my skills after we're done. I'm a loot goblin build. Nice. I have a suppressor for this one, right? Yes, I do. Okay. Oh wait, I wanna load up my rifle's gun first. 0 ammo. That's not how you get into the. Okay. Okay. Yeah, I had a lot of stuff. Okay, great. Okay. Let's go, boys. Let's go. Blaming everything on the government. Okay. It's raining a lot, which is great, which means I don't have to actually water my plants. Right? Where are they? That's what a sports car does. It sports. Let's give my schizophrenia some break. Let's smoke a little bit. Okay. 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 Dude, I love Zombie. We're on a. So what we're doing right now is we're traveling to further off to the west of Rosewood, and what's gonna happen is I'm probably gonna slow it down to maybe 20. But what we're gonna do is we're gonna be going to the west of Rosewood to actually find a military base. But we need to cut off some trees. Um, yeah, I hope they actually have access. Um, we're going at 30. That's fine. That's fine. All's good. It is okay. Okay. So other things that I like about Zomboid is because of how difficult the game is. You're forced to really think about the choices that you make. Like for example, time. Time is a precious resource, so you have to make sure you use your time wisely. Because if you do your book reading during the day, you can't really go looting later at night because it's so dark. It's so dangerous, right? So because we started our raid late at 4 p.m., it's gonna be a lot more difficult when we're passing through uh, when we're passing through the forest stuff, right? That's gonna be a challenge. The last time I passed through it, me and Silas we needed to cut down some trees just so that we're safely gonna be able to like pass through and stuff. Just making sure my friend doesn't get lost and stuff. Suppose with the can of gas we reached Louisville, no problem, but I'm driving, so had to abandon my pick van. Yeah, there's some supplies there on the road. Check for bags. I dropped it since I got. Yeah. So we'll just go ahead and do this raid first, and then we can probably offer some help to the other players later on. But these are some two friends of mine, random strangers. The people I've been helping recently. They've been offering me food, dude. I haven't gone on a food run for so long. They've been stocking me up, man. Yeah, it's good. I really like how Zomboid is really realistic, really configurable. Like it has headlights, it has the headlights like that, and it has a heater on that you can turn on if it's too cold. You can lock your trunk, you can lock the doors. It's pretty cool. Convoy lang, convoy. Alright, let's just keep him safe. To reach safe missions. Fight door with you guys. Dude, I love Zomboid so much. I'm gonna speed up a little bit so I can just catch up and just... Like, this is how fast the car can go. Alright. Like there, alright. And then I'm gonna type a bit. MG to help scout out to LV after this raid. Oh, I wasn't looking for. How would I have known that there was a zombie there? Okay. Okay. Let's take care of the car. Okay. Jesus Christ. Okay. So these are car wreckages that you can actually dismantle with a propane tank, a propane torch, and that grants you some metal parts. So that's really, really convenient, especially when you're trying to up your metal working skill. Okay, so roll. Oh, did we get hit? So I'm just gonna zoom out a bit. We're gonna reach Rosewood first before we actually... So Rosewood. Turn left. I didn't know they had that sign. It's pretty cool, man. Okay. So we're gonna... Okay. So many zombies, dude. Will they end? It's good. There we go. Cruise control. Okay. Yeah, we all get invested in our characters. It's actually pretty good that we left at this time, so that when we're in the military base, it's actually late at night. Then when we get out, it's actually morning. So maybe the timing is just right. Not entirely sure, but we'll see. Sure. Hmm. So we're gonna take out our weapons now. You can actually just take out my rifle, actually. Oh, dude, careful. Not entirely sure how many I'm attracting with my gunfire, but we'll see. So be careful. We need to cut down smaller trees. They're gonna slow down our cars. Better. That was my fire. So we can cut this down. I'm getting hungry, dude. Like in real life and in game. Okay. We have food on top. Oh, I'm eating a piece of chips. Dude, this is so terrifying doing this at night. Holy shit, I'm so happy we're doing it as 3 people, dude. This is so hard to do alone. Okay, we're moving along. Moving along. Let's go, let's go. Let's go. Oh, 565, dude. That's just $5. Dude, this is a lot easier than the first time I actually did this raid, man. It was a lot harder last time. Take some vitamins, I think, to drop some of my fatigue. Okay. Just covering that one already. Dude, it's super fucking scary. Okay, let's go. Drop. I'm recovering my stamina. Layo pa. Oh my god. It's so far. Okay, okay, we got this. Dude. Fine, fine, fine. We got this. Oh. There's a tree there. We're good, we're good. Fine, we're hungry again. Here, good, 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 good. Some zombies behind us, but it's all good. Fine. He's gonna ruin my tires. But it's okay.